Hello dear students of plus 2 medical and non-medical respected teachers. Today I am going to discuss conversion of a galvanometer into ammeter as well as voltmeter, because galvanometer is a device that is used to measure current, but it is very sensitive to measure large current and large voltage in electrical circuits. We have to convert a galvanometer into an ammeter and a galvanometer into a voltmeter. So first of all, we'll convert a galvanometer into an ammeter. Now, a galvanometer can be converted into an ammeter by connecting a shunt resistance, that is a parallel resistance S, to the galvanometer. This is known as shunt resistance. So, a galvanometer connected with a shunt resistance parallel to it becomes an ammeter. So, shunt resistance is a very small resistance and which shunt out current or bypasses the current through the galvanometer. So, S is a shunt resistance. Suppose I is the total current that is to be measured. Ig is equal to maximum current that can pass through the galvanometer. So, this is galvanometer, say resistance of galvanometer is G, Ig is that maximum current that can pass through galvanometer, and S is a shunt resistance, and this whole arrangement is known as an ammeter. So, suppose I is the total current that is to be measured, then by junction rule, so Ig goes through galvanometer, maximum current that can pass through galvanometer, and I minus Ig passes through the shunt, and again at point B, Ig plus I minus Ig becomes I. This is how current travels in this circuit. Now, as galvanometer and shunt resistance are parallel to each other, so potential difference across G or potential difference across S must be equal. So potential difference across galvanometer is equal to potential difference across S. Potential difference means current into resistance. So through galvanometer, Ig current, G resistance, Ig into G must be equal to I minus Ig into S, or S is equal to Ig into G upon I minus Ig. So knowing resistance of galvanometer, Ig, maximum current that can pass through galvanometer, and total current that is to be measured, we can find shunt resistance S. And by connecting a wire of resistance is equal to shunt resistance parallel to the galvanometer, so we can convert galvanometer into ammeter for desired value of current I. Also, Ig into G plus S, from this equation, Ig, we take this IGS left side, Ig into G plus S is equal to Is, or Ig is equal to I into S upon G plus S. So knowing maximum current that is to be measured, shunt resistance value, and galvanometer, we can find maximum current that can pass through galvanometer. Suppose Ra is equal to resistance of ammeter so formed. So total resistance of ammeter so formed after parallel combination of G and S. Then Ra will be equal to G into S upon G plus S, because G and S are in parallel. So parallel combination, equivalent resistance is given by R1 R2 upon R1 plus R2. So in this case, R is equal to G plus into S over G plus S. Now, as S is small, so when we multiply small resistance with large, it becomes small. We divide small quantity by large quantity, so it becomes small. It means resistance of ammeter so formed is very, very small. That's why ammeter is always a low resistance device, and that's why ammeter is always connected in series in a circuit. So ammeter हमेशा series चलाना है electrical circuit ਦੇ ਵਿੱਚ, क्योंकि एक low resistance device है. And for objective question, resistance of an idle ammeter is 0. So idle ammeter has 0 resistance. Then how will you convert a galvanometer into voltmeter? So a high resistance R connected to galvanometer, then we get a voltmeter. Suppose R is the high resistance connected in series with the galvanometer. So Ig is the current that can pass through the galvanometer. V is the potential difference that is to be measured. So R is high. Again, I is the maximum current that can pass through galvanometer. Then V potential difference that is to be measured. Then by Ohm's law, potential difference is equal to current into total resistance Ig into R plus G, or V upon Ig is equal to R plus G, or R is equal to V upon Ig minus G. Knowing maximum value of current that can pass through galvanometer, resistance of galvanometer G, and voltage that is to be measured, or potential difference that is to be measured, we can find value of R. So by connecting this much value of R resistance in series with the galvanometer, we can get a voltmeter. So knowing V, Ig and G, so R can be found. If R is equal to resistance of voltmeter so formed, so R is equal to R plus G. As R is high, G is also high, so R plus G is high. So voltmeter is a high resistance device. That's why voltmeter is always connected parallel to the resistance or battery when we have to find potential difference, and resistance of ideal voltmeter is infinite. So in nutshell, we can convert a galvanometer into ammeter by connecting a shunt resistance in parallel with the galvanometer. So ammeter is a low resistance device and it is always connected in series with the circuit, and resistance of ideal ammeter is 0. A galvanometer can be converted into voltmeter by connecting a high resistance in series with the galvanometer. So voltmeter is a high resistance device. That's why it is always connected parallel in electrical circuits, and resistance of ideal voltmeter is infinite. So thank you, all the best, be happy, stay tuned till next video.